The number I want to talk about is 6174, and it doesn't seem to have anything which is unusual about it. But Kapreker showed that if you carry out a procedure, which I'll outline for you, it always comes to this number. The conditions are that it has to have 4 digits, and these 4 digits mustn't be the same. So you have to choose maybe 3 the same and 1 different, or all different. It doesn't really matter. But you don't choose 1111 or 0000. So I asked you to choose one at random, and you said 9218 is your starting point. Now the first thing you do with this is to put that in the order, the largest number first, then the next largest number, then the next largest number, and then the smallest, and then the other way around, 1289. I've rearranged these digits in the order, highest to lowest, lowest to highest. And then what you do is take this away from that, and when you do that you get 2, and then you carry 1 9 into 2, and I get 8532. Now this is the new number that you put into this machine. You arrange that in order with the highest to lowest, which it turns out to be right straight away, and then the other way round, 2 3 5 8, and you take one away from the other, and there we are, 6174. So you've been really kind to me, because I've only had to go through this iteration twice and I get to the number. Well, if I got to this number and I do it again, I would have, let me see, 7641. I've got to get this right, and then 1467, and I take this away from that and I get back to 6174. And if I were to do that again, I would get this and then that, and it would go on forever. The whole thing with this procedure always converges, always ends up with this number, and when it's got to this number, it's stuck in a perpetual loop that will always bring you this number.
Any 4-digit number's going to...
You can't have 1111, because if you rearrange that into the other order, you get 0000. It doesn't work if all the numbers here are the same, all zeros, nines, whatever. That would not work. But anything other than that, it's going to converge to this number. This is the one that's known as the Kaprekers Constant. If you want to look it up on Google, that's the number that really is associated with this work of an Indian mathematician who must have had more time on his hands than anybody else if he's going to be playing with numbers to try and find something like this. But that's what mathematicians do, and I think it's beautiful.
I see you've got some spare room on your paper. I'm going to give you another random 4-digit number, and let's see if it works. I'm going to make this up off the top of my head.
You haven't got anything on the top of your head, but that's a wig, isn't it?
2984.
2984. So I have to first put it in the order of the numbers, and then change them around and take one away from the other. 1, 2. I've got the Kaprekers number in 3 goes, so you just chose one at random, and it took 3 goes to get to it. Oh, it's very appealing. Not everything has to be useful to be appealing and fun, and this seems to be fun.